So we very briefly alluded to gRPC and GraphQL last week in the microservice ecosystem overview. So today we're going to go into a bit more depth on those two formats of data interchange. We'll talk about REST and where REST is at, and also some motivation for why we want to use these different technologies. And of course, we're going to talk about trade-offs. Talk about trade-offs in every lecture. So problems with REST. Now, this is kind of an interesting thing where you have your back end and then you have a front end. Let me draw this on the board. Where did my whiteboard markers go? Here they are. Okay. So here's your back end. Here's your front end. And your front end and your back end will talk to one another. And to date, we've just said, okay, we're going to define a series of REST endpoints. We're going to have our create, read, update, delete, and then we'll have a bunch of different endpoints. And it's kind of all been arbitrary. Like we've just given you some principles, and you've gone and done and built your API in SENG2. You've done 153 and other projects. But the problem that happens in reality, like at a theoretical level, it's all fine. But let's say you're a backend team and you have a front end team. And as the backend team, you say, okay, we're going to build this API, and you build all the endpoints and you design the API and you think, okay, that's really logical. And then that makes sense to us. And then the front end team, it doesn't quite match their use cases. And this is, again, what I was just talking about before of sometimes it's very hard to generalize, and sometimes you have to build to a particular use case. Otherwise, you don't end up solving anyone's use case or the right use case, which in this case is just the front end of the application. So you get things like, okay, well, maybe we want to list all of the projects in the system. So we have a REST endpoint, which is like get /projects/all. And what that gives you is a list of IDs. And to the back end, you're like, yep, the back end API developers are happy with that. And then to the front end, it's like, well, now we've just got a list of IDs, and that's not enough information. So now we have to make, for every single project, like 4 P in projects. Now we have to make another GET request, like /project/details. So all of a sudden, you've gone from making one API call to N, right, where N is your number of projects. That's slow, right? It takes time for those bytes to travel across the wire. It's not as well designed. The front end and the back end don't quite interoperate as well as we'd like. So that's what we call underfetching. And then overfetching is a similar thing where maybe you make an API call and it gives you all this information back, but you only just wanted one tiny piece of that. That's called overfetching. And the problem with REST is that it has this very fixed structure that you can't just say, no, here's exactly what I want. Give me that. It just gives you a predefined set of information. That's the first problem. The second problem is that there's no type system. Now, did everyone do 153.1 back in the Python days? Did anyone do it in the JavaScript days? Okay, cool. You're all old. So who had a bug where they'd do something like in your Flask layer, you'd have like your wrapper for your API endpoint, and you would do something like forget to typecast the ID from a string to an int. And because it's Python and it's all dynamically typed, you wouldn't get caught anywhere. And then all of a sudden, you've got this string floating around that you think is an int, and something that's not working. Back when I taught 153.1, people would come to me in help sessions, and I wouldn't even need to look at their code. I'd be like, here's your problem. And they would go, wow, how did you know? Right? Like, it's just a common thing. That's why we love typed languages. That's basically the reason 153.1's in JavaScript now. And that's great at the language level. But we also kind of want that between the front end and the back end itself, right? So that you're not just kind of arbitrarily casting bits of data that you get like you do in REST. So there's no assurance on types in your requests and responses. And then it's very slow to send JSON across the wire. Like think about the amount of white space in your JSON string that gets sent in a HTTP request. That's all getting sent across the wire because it's all plain text. So that's some problems with REST. Now, I will preface this by saying REST is still the most widely used and mature framework for data interchange that's out there. The reason we're saying you shouldn't use REST in this course, and again, you can use it if you want, you'll just lose a couple of marks, we want you to, the reason we want you to not use REST is A, so that you learn something new, and B, so that you learn what industry is moving towards, because it's still the most dominant paradigm at the moment, but it's slowly going out of fashion, and you see these things happen a lot. Okay, so the first new modern tool is called gRPC, and it's one of those dumb acronyms where the first letter of the acronym is just the acronym itself, like YAML. It really annoys me. This gRPC stands for gRPC Remote Procedure Calls. And the main idea is that, let's say you have two microservices and you want one to talk to the other, right? You want to call methods of service A by service B. At an abstract level, it should just be like, remember how last week I talked about, you know, in your monolith, you just have two Java classes that call methods from one another, and it's all just object-oriented programming, right? Whereas in microservices, you're now sending bytes across the wire. You've actually got a whole network to deal with. gRPC says, well, you're still sending bytes across the wire and have a network to deal with, but let's treat it as if it was just two objects being shared with one another. If you've done 2511 and remember like the entity response objects, where you have your model and then you create your response objects, which is just like a snapshot of the system at that point in time, and then that gets sent off to the front end. It's kind of similar to that, where how it works is that a client application can directly call a method on a server application, and it's just kind of sitting there as a local object. Implementation-wise, so the server side implements a certain interface and then runs a server to handle client calls. And then the client has a series of stubs, which appear to them as just being normal objects, but under the hood, they're actually working and communicating with the server to get the response. What else did I have to say there? Designed for building distributed applications. And again, they're based around this idea of you define your service, you define a series of methods that have requests and responses. Again, it's kind of similar to REST, but it's more just like an object.
Are there any downsides to using it?
Yep.
But still be beneficial.
We'll talk about that in a second. I think I might answer the question. So the way gRPC sends information is using something called a protocol buffer. So what you do is you specify your interface in a .proto file, and then that's just like a data structure. And what will happen is at runtime, before that, at compile time, you will actually run a command, and what it'll do is it'll take your proto file and generate a series of files in that language. So if you're working in Python, it'll generate a series of Python files, which are essentially like your response objects from 2511, or they're essentially a series of data classes or structs that say, here's all of the different messages that we're working with, and classes to invoke those messages and actually call the methods. You kind of see what I mean in a second. So all those classes involve getters and setters, methods to serialize and pass the data, and to actually send the bytes from the client to the server or vice versa. Protocol buffers are really great because, again, we're not dealing with big JSON strings anymore. The data is more compressed, right? We're saving a lot of space and much more performant as a result, because we're sending serialized bytes. Here's an example of a message. You can see it's literally just a struct, right? And you can specify data types, so it is strongly typed in that sense. And this is an example of you create a message, and then you send that as part of a request or response. Here's an example of a more concrete API where you say, okay, here's just this service. It has a method, say hello, which takes in a request, which is a message, and returns a response. Again, similar to REST, but you get the benefits of more type safety. You get the performance benefits of protocol buffers. And you also get the fact that it's just like another object that you can kind of call in your language. Any questions so far on gRPC? Okay, trade-offs. We just talked about that big performance gain. You can also use TLS, transport layer security, which is like what we talked about last week, where you want to have your east to west communication, your security between microservices and encryption. The downside is that it's harder to analyze payloads. It's harder to debug because you intercept a gRPC request, and it's all just like serialized bytes. So you need to do a bit of translation there to turn it back into the stuff you want to work with. The other problem, which goes to Will's question, is like limited browser support. So gRPC is not your framework for building customer-facing web apps. Like you wouldn't use it to replace your front end and your back end communication. That's what you'd use GraphQL for, because it's not very good for working with browsers. It's more for saying here's service A and service B. Very much a microservice technology. Does that kind of answer your question? Yeah. It depends. Like if you were working on a small microservice app and you have service to service communication, then yeah, for sure. Like you can have simple APIs like this one, but not the best for front end, back end. So this is a big oversimplification, as in you can build a gRPC API just using this. It's very language specific because of the fact that it will actually compile code in that language for you to use as the classes. But there's other things you can do as well, like have streams between the client and the server. There's heaps of documentation, and this is more just an introduction to the concept. Any questions on gRPC? Yes. How much of it gets abstracted away? Most of it. Like you have to create the protocol buffers yourself, obviously, define the interface, and then compile those data access classes. And then you have to do a bit you just have to, kind of similar to REST, where you start the server. You actually have to invoke those methods in certain instances. So you might say like, oh well, given this condition, I'll actually call this method of this API like you would as a class. But again, that's just all using the software, right? Like I wouldn't say there's not a whole lot of extra overhead you have to do on your own. There's the source where I got a lot of this information from provides like examples in I think every single language that gRPC is supported in, and it gives you like a dummy project that you can spin up and actually test stuff out. So I would recommend checking that out. It's in the further reading section of these slides. Cool. Yeah, I've worked a bit with gRPC before, but not my area of expertise. I spent 6 months on a GraphQL team though, so I know way too much about GraphQL. But let's take a break before then. We'll do 10 minutes and then come back at 10 past and then talk about GraphQL. Cool. Sorry? Oh, okay. Oh, no. Nah, I'm okay, thanks. I'll eat after.
Yeah. It does feel very good.
Hey, Luke.
I was going to mention about this, something I'm kind of,
Yeah.
I'm guessing kind of the assumption is that everyone's making an importation API. It's kind of hard to make a process one.
You can make a process one that relies on, like I would team up with another group and be like, okay, you're using this like doing data for diseases or whatever.
Yeah.
You can build the import one, and we'll build the process one.
Yeah. But you'd kind of need to import APIs, wouldn't you?
Why do you mean to?
Because you want to kind of find a correlation.
Oh, it depends. Like, yeah, you could do that. I haven't thought about it super extensively, but you could do processing just on a single data set.
I was kind of thinking, for example, I've been speaking a bit with their team.
Yeah.
And they're doing transportation.
Oh, okay, cool. Very nice.
Kind of based on maybe weather, for example.
Yeah, yeah.
So now they're kind of banking on a interpretation of weather, right? But if we were to do that, then we kind of need to take someone else's some other thing, right?
If you want to do processing.
Yeah. So, well,
Yeah.
because we kind of make in sprint 1, and I'm assuming make processing.
No, like so sprint 1 is to build the API. Sprint 2 is test and deploy, but it's also like a chance if you just want to go and build more stuff, you can do that.
Yeah.
And then sprint 3 is again build more stuff and bring it all together. Like it's like we'll kind of give you things to do, but it's your project at a certain point. If you say like, this is kind of going back to your thing earlier of like, are you just planning for sprint 1 or are you planning for the whole term? It's like, if you like, I think what most groups will do is that they'll, you'll set out like your measures of success and stuff, and then you only get half of it done.
Yeah.
Right. And then you might want to spend the rest of the term just working on it. And the good thing is you've got 5 people and it's your team. As I said, we'll try and make sprint 2 and sprint 3 such that you like, we'll say you need to do these things, but then there's also like a certain percentage which is just like up to you. So if you want to build another microservice which finishes off that project, you can do that. If you want to improve your existing one, you can do that.
I think the main question that I have is, in order for us to define our business proposition, we can't have to go ahead, right? We have to understand what.
Yeah, you can do that if you want.
And also, if I'm just, let's say like our team does a weather API import, right? It's basically inevitable that down the track we're going to have the exact same value if because we're going to use their APIs.
I think I still stand by like you can have the same thing.
Yep.
Like
But for example, like your idea with transport, unless if they use yours and I see what you mean.
Like,
they can
with
use
transport,
disease
then you can
transport.
I think one thing we thought about is you can analyze or process the data and trends that might justify the need to privatize. Whereas that's to better accurately then there needs to be bus replacement. You can use the same data sources.
Yeah, exactly.
And it's not assessed on you both use the same source. It's assessed on how you turn that.
Part of the thing was if I took your team, okay, you could take our weather information, we could take someone else. Yeah, we've spoken to 2.
I think it's so like you guys like for example, you can go talk to your team and see if you can come up with an idea finding weather and transport. Your idea for it. We sort of have an idea.
Yeah, and it can be.
And you just know that we kind of need weather.
Yeah.
And if you guys can come up with something that combines weather and transport, transport's getting done by us.
Yeah.
You guys can do weather, so we can both benefit from each other. If you guys just come up with an.
Yeah.
This is where the.
I was just saying the other thing is, I think it's just rough because right now there's nothing in there's no. So it's hard for us to visualize what we can use together because there's nothing there. We have to put things there first.
Yeah.
And also,
I think that's why it's a bit tougher.
In terms of like your API Swagger documentation, that's where your standardized data set will be, right? So like because they're doing transport, obviously the standardized data, standardized form.
Well, that's there isn't like if you read the spec, there's the event data set like specification. So everything that goes in the S3 needs to adhere to that. And the point of that is so that you can put in data in the S3 and then your group or someone else's group can pull that out and they'll be all in the same standard.
So to begin with, we all have to do an input from one of those specific data.
Not necessarily.
But I think I get what you're saying. It's tough. I think for us to visualize not doing an import.
Yes.
Because there's nothing there.
Yes.
We can't go. Okay, look. Because for example, if I was in a team, whichever other term this is wrong, and I look and go, okay, someone's already done weather, someone's already done transport. I think we can put these 2 together.
Yeah.
But right now we're like,
there's nothing
there. So we have to import.
So but
we can't because there's no chat on Ed about who's done what, who's going to do what.
It's a bit of a gamble.
Yeah, that's why we're kind of gambling on.
I was going to make I forgot to do that. You can make a mega thread and have that as a. Yeah. That's a good idea. What was I going to say? You'll be able to like that's what the platformization thing's really useful for. You can build your API, and then like it's generic enough so that someone else's business case can come along. Like maybe you have two completely different business cases, and they both use your API because they have the same need.
I just feel like you have to like that. That'll be that'll be during like sprint 2 that you'll figure out. Oh,
yeah.
And then our business propositions aren't. Like, I haven't even, because our business proposition, our tutor was like by the end of week 2.
I think you just my question to me.
I think I wasn't. That was
yeah. So Manfred was saying that the engineering proposal, the business value was for our end product.
Yeah.
But
how do we know?
But Nick is saying you're just justifying your microservice
right now. Okay.
You're not justifying. Okay, this is what our end product will bring.
Yeah.
So right now, what's the value of?
You might bring that towards the end product, particularly if you've got that in
Right
mind.
now, the focus would be on the microservice.
Yeah.
Not the end.
So we're running business value.
Like
we're simply a business that has this microservice that could do a certain amount of things.
Yeah. Yeah.
Like the way I've written ours is, I'm just justifying why.
I don't know why that's odd.
That's right. I had one other thing I was going to say, but I can't remember. Yeah. It depends. Like if you've thought, I know we haven't going to given you everything you need to do, but like if you want to plan as far ahead as sprint 3, you're welcome to. If you want to If you just want to plan for sprint 1, that's fine as well. We'll only mark you on what you're currently delivering. Because the thing that I find really useful about this format where we get you to plan and build the whole thing by the end of week 4 is that we can, like, because if you do the plan, you're like, oh, that's a great plan, but it's, you know, the plan's only as good as like those who see it through kind of thing, where it's like you need to actually build the thing to see if it works. So in week 5, we'll assess you on not just like what you proposed, but did you actually deliver on that? So in that sense, we'll just be only assessing what you've done rather than what you're planning to do in the future. Mm-hmm. Yes, that was what I was going to say before. That's right. If you're building a processing API, you're welcome just to use dummy data for this sprint. And you might say, oh, we're waiting on this other team to finish doing their import API so that we can use their data when it comes to actually doing the real thing. And we'll use dummy data for now. That's perfectly fine. Cool. I feel like we lost a bunch of people. They ran. They didn't want to do GraphQL. No, I feel like the 12 to 2 is just like a rough slot when you're like, I should be having lunch at some point in this time. Anyway. Oh, I see. That's good. Okay. Online people, please give us a voice if you have any questions, but I'm going to keep going. GraphQL. So GraphQL or Graph Query language is, you can kind of think of it as being a bit like SQL for web APIs. It's a query language for APIs and a runtime for fulfilling those queries with your existing data. So again, it's like you're not building a database as your API. You're just building a layer of abstraction that someone can come and query for information rather than you giving them sort of fixed bundles, which has the overfetching and underfetching problem that we talked about before. GraphQL was developed by Facebook, which we'll talk about the relevance of that later. And it's really useful for public-facing APIs, which is any API that is out on the internet that anyone can call, particularly if it's like a gateway or an edge service, as we talked about last week. You build it in GraphQL, and then you have a bunch of services that all talk to each other with gRPC. Okay, so to make a query, nice and simple to start with. We say, okay, I want a hero, and then just kind of like an attribute on a class. We say, well, a hero has a name, so we're going to ask for the name. And then the response we get from our GraphQL server is in the same structure as the query that we asked for. So it'll give us the hero, and then within the hero, a name. Let's make it a bit more complicated. So a hero has a name, but they also have a series of friends. Now, kind of like your arrays and your pointers in C or Java or like whatever you want to think of it, those entities themselves will have their own subfields, right? Like each hero has a name, but friends also have a name. So we can kind of have parent and child fields nested within one another and keep kind of just going deeper and deeper as we sort of query more connected objects. So here we've got, we query hero, name, each friend has a name, and again, our JSON reflects that structure in the response. This is where things get a bit more complicated. You can do cool things in GraphQL like make a fragment. We haven't seen what this is yet, but this is just like a type where we say, okay, give me all of the heroes in Empire Strikes Back, and then it'll include this comparison fields fragment as all of the fields to select on, which in this case is the name, the films they appear in, and then the friends they have. Similarly, do the same thing for Return of the Jedi. The response isn't here because it was too big. Don't have to worry about too much, but here's an example of some more complicated things you can do in GraphQL. And it functions very much like a language itself, where you can pull out these fragments and then reuse fragments in different places of your query. So a full query kind of looks like this, and we use the syntax query, the name of the query, and then we can do things like pass in arguments. So we specify that the episode is Return of the Jedi, and then pass that in as an argument to the query itself. That gets given to these fields here. We'll talk about data fetches and resolution in a second, but you can think of this as connected to like a listener in your API that says, okay, fetch me the information about this hero, and we're going to pass in an argument, which is the episode that they were in. Similarly, these are all also fields that are attached to data fetches or resolvers in your GraphQL server that says, okay, fetch me the name, fetch me the friends of this hero. Cool, and again, we get the same structure. And this is just passed in via, when you use some sort of GraphQL client to make GraphQL queries like you would with Postman and REST, you can see how you pass these in as just like, kind of like header variables, you can think of them. So queries do obviously queries. They allow us to read information. The next one is a mutation. I'm sorry about the syntax highlighting, by the way. I set it to automatic and it just kind of went wild. Yeah, it's a bit weird. Mutations are our put, post, and delete. They allow us to make stateful changes to our API and allow us to do things like create new objects, update existing ones, and delete entities in the system. And they can also give us payloads back, which we can ask for fields like we would any other GraphQL query. So here we say, okay, I'm going to create a review, and then we'll get back this sort of like, you can think of it as like a review object, and then that will have a series of stars, it'll have a commentary, and we can ask for those fields. Yes?
So like, going to REST, create the info, and the $F and
Yeah, exactly. Yeah, a mutation is like, you know, this would be a post operation. The confusing thing is, I think in actual, because the thing about REST is it actually follows HTTP codes, right? Where you make, you know, get, post, put, delete. I think this might even just be a get, which is kind of confusing because GraphQL doesn't align with those HTTP standards, which is one of the downsides of it. I didn't list those in the slides actually, but that's the thing. But yes, you know, these function as arguments that allow you to give data and create an input. The other really important part of GraphQL is it has a strong type system. Has anyone here worked with TypeScript before? A few people. Yeah, cool. So this is kind of similar to TypeScript in the sense that, I mean, most of you've done 2511, you've done the idea of you've got interfaces, and then you can implement that interface, and then you define a type, and then that has fields. And so it's the same idea, except rather than having methods of functionality, you just say, here are all the fields associated with this type, like our interface character. And then a human is a concrete type of a character, whereas the character itself is abstract. It's not a real thing. And then you can put this on the right-hand side of your schema, for example, and say, well, you've got this field hero, which returns a character. And then we can select information about that character, like what's the name? What does it appear in? And this forms part of your GraphQL schema. So like with the protobuf, where you define your schema in a .proto file or your interface, your schema is like the way that an API client or your GraphQL client can say, here's the query I'm going to make, here's the fields I'm going to select on, and it will tell you what these types are, and it will actually enforce these types as well. Any questions? Yes. That's a great question. Exclamation mark as a general thing in programming means you have to include this. It's non-nullable. So sometimes like you could leave the friends as being blank, whereas this is like you have to include this particular field. That's a good question. Yes. I think so. If you're like you're a backend that's implementing this schema, and then you return null for the name, GraphQL will go, hey, that's a problem. Like the GraphQL server, like infrastructure itself will say, hey, you can't do this. That's what I mean by the type safety and the type enforcement, because if you're a client, that means whenever you query the name, you know that field will be there, right? You can have 100% assurance, and you don't have to put in things like error checking to make sure that it's not null. Cool. All right. So GraphQL servers and clients. We have the schema which we've defined. This kind of, when you work with GraphQL, you need to disambiguate between these parts which will form your schema, which go on the actual server, and these which form your query. That takes a bit of getting used to, but you will figure it out. Looking at examples is the best way to learn from that, where you say, okay, well, here's my schema, and then here's actually where I use my schema by calling parts of your API. Your programming language will have a library that will allow you to create GraphQL servers. GraphQL Java calls the things that we use to resolve fields data fetchers. Every other language calls them resolvers. But essentially what your API will consist of, or your API layer, is it'll have a series of data fetchers or a series of resolvers that say, okay, for every single part of this schema, right? Like when I say, give me the hero, it will call that data fetcher and that will be populated with all the information about a hero. Similarly, all the information about a name, about friends and that sort of thing. And then you can do things like pass information from the parent data fetcher to the child data fetchers. And there's lots of parts to it and it's kind of complicated. I worked in a team for 6 months that their entire job was just a GraphQL API layer. That's how complicated these things can get. So other than that, I don't have anything that's too specific to say. Then on the other side, you have GraphQL clients, which you use in the front end. There is a bunch of different GraphQL clients out there. Each of them have very specific use cases and things that are good about them. I would just do some research and figure out one that's nice and simple for your case when it comes to building a front end, because they'll be able to do, like the main thing you guys want is simplicity. Some of them are really optimized for performance. They do cool things like caching and lazy loading. But you won't really have to worry about that most of the time. Okay, super big thing with GraphQL is pagination. And you'd probably appreciate this being used as a software is like, how do you deal with large volumes of data? What if I query an API that says, maybe give me all the projects in Confluence, for example. We just created 30 Confluence spaces or 30 Jira projects for you guys to do your groups. What happens in 10 years or 5 years time when there's 2 courses running a term and there's 30 groups per course? Like that's a lot of data, right? And we don't want to have to send that all at once. So what do? We split it up, right? And we do that by splitting it up into pages. You all do pagination in the 1531 project. It's a nice little part of it, which I don't know if it's still in it, but I think most people notice it. But when you implement send all the messages from this position to this position as like a index in an array of messages that's been sent in like a channel or something, that's pagination. So we separate the data into pages. And this is a really big thing for Facebook, who are the developers of GraphQL, because think of a Facebook feed, right? Like you basically just get this continuous stream of information, same as with TikTok or any other feed-based software as a service. You want to get this continuous feed, and you don't want to have things like the same post appear twice, right? That's bad. You don't want posts to be missed accidentally. That's also bad. Facebook, not great for that. Doesn't work half the time, but you need to be able to keep track of things scalably. So the way we do that in GraphQL is a concept called connections. And you'll see why it's called connections just by looking at this query here. So I have a person, they're a user. I say, give me the user with this ID. That calls the data fetcher, resolves the field. And I can say, okay, what's their ID? What's their name? And what friends are they connected to? And I just want the first 3. What that will give me is 3 edges. And each edge has a cursor, which you can just think of as being like an index, right? An offset in the in your page. And then the other part of the edge is the node, and that is the friend itself. And each node, of course, is another person, so they'll have an ID and a name. Now, we're using a lot of graph speak here, right? We're talking about edges and nodes and connections. And so this is where the graph in GraphQL actually comes from, because obviously when you're talking about Facebook, right? That's the canonical graph analogy, right? It's a social network and people are connected to one another. You liked this post and you liked this post and you're friends with this person. So that's where the concept of a connection comes from. We can see that, a bit more clearly here, where we say, okay, give me this user and give me all of the friends they're connected to. And the connection itself is an edge, right? And then on the other end of that edge is a node. And then the other part of the connection is a cursor, which is just, as I said, an index of where we're up to. We can define that in GraphQL. Here's our user type, and we defined our friends connection, and again, this will be a connected to a data fetcher, and that'll return a user friends connection type. It's just a page, which is a connection which contains page info, which is just things like what's the next page that you need to go to in your pagination, and then a series of edges, which each contain a cursor and a node. Any questions on pagination? Yes. No, sorry. You could do things like this query back up here. We say, give me the first 3 friends, and You're like, well, Nick has no friends, so right, like you don't get any. That edges array is empty. Yes.
Where do you have all the data? Is it from the database? You've got all these friends and connections with database. Having the data in your
That's a good question. So the question was, is what's, I guess, like, what's the layer of abstraction? And like GraphQL isn't like SQL, because when you have SQL, you literally have direct access to a model. Here's a bunch of tables. Here's another table. This is connected to that. This, ER diagram, blah blah blah. And when you say, insert into blah blah blah, you're directly changing the table itself. Obviously, there's abstractions there because it's in memory it's looks slightly different, but you are directly interacting with the model. Whereas here, there's still a layer of abstraction between the API client and the model itself. So the role of the API layer or your data fetches is to, like, it depends on your system architecture. So a lot of the time, it might just be orchestrating a bunch of like if you have a, sorry, let me rephrase this. It depends on your system architecture, where it's like, maybe if you have a monolith and you've got a GraphQL API at the top of the monolith like this. So here's a big monolith, and then this is your GraphQL API. And so the role of your data fetches is to go and say, okay, well, I'm going to call this service, which these are all just Java classes, and then maybe down here is your database. And so these services will also call like a data access layer, which is like your ORMs or your layer of code that's just about read and write to your database. They interact with those, and then they interact with those, and then things eventually filter up all the way to the API layer. That's monolith. If you do it in microservices, similar kind of thing, right? You've got your Edge GraphQL API. That makes a bunch of gRPC calls. That goes to service A. That talks to the database here. That talks to B as well. So it all depends on how you've defined it, is the answer. How you're defining your choreography, your orchestration, whether you've got monolith or microservice. But generally, like, unless it's a very simple application, you wouldn't have your API layer interacting directly with the database. And that kind of defeats the purpose, right? Is you want to separate it all into separate layers and have this sort of layered architecture. Any other questions? No? Cool. Okay, we did all that. Okay, trade-offs. The good parts of it. It auto-generates documentation. When you create your GraphQL file and define your schema, you can just include comments which say, this is what this field means, this is what this type means, and that will auto-generate a series of docs that you can see when you're actually making API calls to your GraphQL server, and it'll say, here's all the types and here's what they mean, and it'll format everything nicely. It also allows for straightforward API versioning, where you can easily deprecate fields and add new fields. It leads to better performance because we don't have this overfetching and underfetching problem. If you go back to the projects we were talking about before, instead of saying, okay, get me all the projects, it just gives you the IDs, and then you have to go and make a separate request to every single project. Instead, we can just say something like project. Maybe we get use pagination, we get the first 5. And within that, you select name, team, the length of time or whatever. And so you can get as much or as little information as you want, and that can change as your use case changes. So there's a little bit more coupling in a certain sense, but then there's also less coupling because your REST endpoint isn't, you don't have to update your REST endpoint if your front-end use case changes. The other thing it does is that in GraphQL, rather than having a bunch of different REST endpoints, you have one single endpoint called /GraphQL, and that is where you make all your queries and mutations to. So when, instead of having a bunch of different REST endpoints that are all kind of scattered and harder to keep track of, you have one endpoint, nice and easy to keep track of, and then you just have your schema, which evolves over time. Cons. Harder to set up, more overhead. It's harder, like the great thing about REST is that you can just spin up a server like that and then make queries to it. You can use curl, you can do this all this stuff, which doesn't take too much effort. GraphQL, there's a bit more overhead required, and I think the onboarding is a lot harder. So if you're going to be using GraphQL for your APIs, be prepared to just go through that process of, just like being patient and figuring stuff out, because there's a lot to it. It also makes caching more difficult. One of the good things about REST is that you make the same call multiple times, your browser will cache the response and just send it back to you rather than just like making the whole request again. GraphQL, that's harder because often each single request will be nuanced in its own thing, and it's much more difficult to cache. Though different GraphQL clients do a good job of trying to implement caching. Yes. I don't know, actually. That's a good question. Yeah, I'm not sure if GraphQL servers cache by default. Cool. I've kind of said this already, but this is a common architectural pattern. You have GraphQL for your public-facing APIs, and then gRPC for service-to-service communication. And then this last one here is like maybe, for a lot of you building import services, they'll actually provide you a REST API. So you're like, well, we have to use REST insofar as we have to make calls to someone else's external third-party software as a service or platform as a service. Any questions? Nope. Cool. Okay, I've got just under half an hour to do. I thought this was going to be the longer one, but see how we go for time.